the beginning of Kubernetes, talk about nodes, the Kubernetes architecture. So I would like to just let me start. Let me show you the screen. So basically, we're talking about the Kubernetes architecture. We're talking about nodes and what are nodes. We talk about cluster. What's a cluster in Kubernetes? We basically say, hey, in Kubernetes there are two main things to know. There is the that is the master node, which basically where you have these components installed: the API server, the etcd, the scheduler, the kubelet, the controller, and the container runtime. The container runtime, you have those ones installed on the worker nodes. We basically say, hey, once you have one or more nodes, basically you have a Kubernetes cluster. We look at, okay, what are the functions of some of this? We talk about the etcd server. That is basically a key value store. It's like a database for your Kubernetes cluster. We look into a scheduler. We say scheduler is basically what schedules your Kubernetes. So, for example, hey, container A, cluster, you want to host a particular pod. Where does it go to? Is the kube scheduler that decides, okay, it should go to this particular node or it should go to that particular node. That's the job of the kube scheduler. We look into that. We also looked into a few more things. We look into the controller. What's the job of the controller? What's the job of the API server? We looked into that. We also looked into what the difference between a master and a node. I basically say, hey, in a master, what made the difference is the function of the master and the function of a node. And what is installed in the master and what is installed in node. I remember saying that, okay, hey, in the master node, you have the etcd controller and the scheduler that are basically installed on the master node. You have the kube API server, they're all installed in master node. So the master node's function is basically to control the different worker nodes, different nodes. We basically said, hey, in the worker node, you have just the kubelet and the container runtime, right? Those are the two things that run on the worker nodes. Basically said the job of the function of the worker nodes is to host the container, in this case the pods. We went a bit deeper, showing you guys, okay, we did YAML basics. We showed the guys this is the basic structure of a YAML file. We looked into pods, right? We say, okay, what's a pod? We say a pod is basically what? The smallest thing you can deploy in Kubernetes. Say a pod is basically what hosts your application. Your application, your host is basically hosting a container, and a container is hosted within a pod, right? So the smallest thing you're going to host in a Kubernetes is basically a pod, right? We looked into, okay, here with this quite a few examples. So you can go and watch the video last week if you want to. It's available in our YouTube. You say, okay, you look at, okay, what's the difference between these two pods? What's the difference between, we saw how to fill out pods using iterative or imperative ways. We were able to do imperative, basically running a command on the cluster, and we spin up an Nginx or a Nginx pod, or we did HTTPD. We also do declarative where we use YAML to deploy it. We did example and lab for all of this last week. So I don't know if you have any questions, you can bring it up. But just want to use 10 minutes to do a quick recap of what we did last week. So we also looked at replica sets. So replica set, what are replica sets? Basically, hey, replica set helps you to maintain a certain number of pods running in your application. That's the basic rule. It can also help with scaling. So what does it mean? It means that if you look at this slide I'm sharing now, you see, let's say replicas 3. Replica set will ensure there is always 3 instances running. So if anything should happen to your pod, one of your pod is restarted, one of your pod is dead, automatically the replica set in conjunction with the kube scheduler automatically bring up another instance to ensure that you always have 3 instances running at any particular time, right? That's a replica set. If I should move forward again, we talk about daemon sets. You say, what a daemon set? You say, hey, job of this guy is to make sure that an instance of your pod is running on every of your node. Remember, guys, node is what pods are running on. So the job of a daemon set is to make sure that an instance of your pod is running on every node. Why is that? So, for example, now if I have 4 nodes now, right? If I have 4 nodes and a master and a API server running on my cluster, if I deploy a daemon set will make sure that an instance of that pod, let me use, for example, HTTPD, will make sure that an instance is running on every node. Why do I need that? The reason why I might need that, if I'm collecting logs for my node, I'm collecting logs of my application. Let's, for example, if you're using Elasticsearch, for example, or if you're using Grafana or Prometheus, you want to scrape logs from your cluster, you need a daemon set, something that is running on every node. Just imagine that I want to track what is happening in my pod, right? In my pod. and I want to collect the logs. If you don't deploy a demo set, that means on a node that is not deployed, you will not be able to collect the logs. So anything that has to do with tracking, monitoring, demo set is involved. The job of a demo set is basically monitor every node and collect logs. So whenever you see a demo set deploy, it's likely because hey, the person deploying the demo set wants to have at least one instance of that demo set or of that pod, or a demo set, which is basically a pod in the background running on every node. That's what a demo set does. We have to talk about deployment. Say deployment is basically a higher level of a replica set, right? With deployment set, you can do rollouts. You can have several instances. You can have like several things running on your demo set. That's the beauty of a demo set. So demo set is actually very, very good. Sorry, deployment. So deployment is like a higher level of replica sets. We did example of this. I showed you guys this last week. We did a lab and we saw how you can create a deployment, how you can I think one of the examples we did, we actually made it up to 5. I will try to bring it up again because I still think it's still open. So, but the deployment is basically useful. For example, if I'm deploying on some application, it makes sense for me to make it a deployment. Then I can have everything concerning it. I can have my databases. I can have my databases. I can have my secrets. Everything stored inside the deployment, and I basically do just one run. I'm going to show you guys. I'm going to show you guys an example of it. We also talked about services. Sorry. We also talked about services last week. We say, okay, what are services? Say one of the good thing about services is that the service is basically used to expose your application. So we looked at I know some of you don't understand it very well. I'm going to try to explain it more again. So say, okay, hey, you built a wonderful application. Call it Dodge app, right? Dodge app is running. You deployed the Kubernetes. How will people all around the world access it? So how will they access it? That's where the services come out. The purpose of the service is to expose your application. Although there are limits to what you can expose. So for example, now there is cluster, when it comes to service, there is cluster IP. There are 3 types: cluster IP, node port, and load balancer. I said cluster IP, if you go for type, which is the default one, if you go to a service of type cluster IP, that service will be exposed only within your cluster. So for example, now I want a service, I want Nonso application deployed in my cluster to talk to Dominic application deployed on the same cluster. I can expose the service and make it work a cluster IP, right? I can make it a cluster IP. I can make it a cluster IP. Those 2 services can communicate with each other. So cluster IP is for service-to-service communication. Node port, on the other hand, is hey, I want to expose a particular service, a particular application only on a particular node. So, for example, remember I say, hey, Kubernetes makes it up of what? Multiple nodes. When you have multiple nodes, when you have a cluster. So if I want to expose the service only on one node, right, then I'll go with node port. The next one is a load balancer. So load balancer. Load balancer, I say, hey, if you load balancer, you have this mostly in managed services, right? What this will help? It helps you to if you do a load balancer, a service like load balancer, what's going to happen is you're going to get a public IP address assigned to that service. So what it does is, for example, in Azure, for example, if you do a service of type load balancer, automatically it will go to your Azure environment, and create a public IP and attach it to that particular service. That particular service you can access that particular service through that public IP address, right? Is one thing. It makes sense to know. So if you want to expose a service externally, you need to make habit after your cluster with the public IP, and you're deploying a service in a cloud environment like Azure, AWS, GKE. If you make that service of type load balancer, automatically it's going to expose it after your cluster. That's for that one. So we did more on services. I deployed the sample service. I showed you guys what it's about. And we did a lab about it. Where we stopped last week was on storage, right? I don't know, do you guys have any questions from last week before I move over to this week? Any questions? Okay, all right. Let's move on. Storage. Okay, somebody's typing a question. Chibuzo, I'm waiting for your question, but just continue. Chibuzo and Leo. I will be talking about storage. What is storage in Kubernetes? If you remember when we did Docker, which the 2 or 3 weeks back, we said what containers are ephemeral. Okay, you're not in last week class. Okay, there's a recording session on YouTube. You can go and watch it. If you don't understand anything, you can chat us up on WhatsApp in the group and we'll explain. And also, maybe next week class, you can bring up the question again and I'll explain. Right? Back to Kubernetes concept of Kubernetes storage, right? One thing to know about Kubernetes is that if you remember last 3 weeks back, I mentioned, okay, so Leo say, is it safe to expose your application to load balancer or using cluster IP is better? Very good question. I like your line of thoughts, and I'll tell you a few things, right? Even though you are rushing, but I'll tell you a few things. So it depends on the needs of the application. So most times the default is cluster IP. You do cluster IP, you now do ingress, you do an ingress and the ingress class and expose that service. I don't want to rush those up because that's another high level of Kubernetes, to be honest. I don't want to go into that, but mostly you only expose if that application there's a requirement to expose it. The few times I've done it, in my environment, in the environment of where I'm working on, I'll give you an example. That was 3 years back. I was deploying a machine learning application that basically needs to be paired by another. So we have basically a cluster of applications. This machine learning application needs to connect with another connected cluster running on GKE, and I was deploying on Azure. So what we did, and then you cannot do. I'm mentioning then, not now. Then you cannot Ingress does not handle TCP connections. Now Ingress can handle TCP connections through gateway API. Then Ingress cannot handle TCP connections. Now it can handle it. So what I had to do was I had to use the load balancer, but make it private. So you expose it to a private IP address. I now went on the firewall, created a public IP address, permitted it to, I'm not talking deep in the code, permitted to only allow connection only from that particular address. So, but that's there are reasons. So just to put it to summarize it, there are scenarios whereby you have to do type load balancer, and you can handle the connections how you want it or through your firewall and everything. There are reasons why you might want to do that. In some cases, you don't need to do type load balancer, right? But if you wanted to pick up, you want a service to pick up, let's say you use a different container, CNI, container networking. If you wanted to pick up a different an internal IP address for your VNets in case of FAKS in this case, you might use type load balancer and just change it from there. Especially if you want the IP address to be static. So I'll just leave it like this. I don't want to go too deep into it.
So,
all right,
so let me just add like a quick tips for everyone here, because basically when you are deploying Kubernetes by design, you are not supposed to expose Kubernetes is not supposed to be publicly exposed to publicly exposed when deploying it. But applications that runs inside those Kubernetes, they are supposed to be publicly exposed, right? So by design, when you publicly expose Kubernetes, you have flawed the security system of Kubernetes itself. So what Noso is trying to explain to you basically is, by design, when you deploy Kubernetes, it is not supposed to be publicly exposed, which means that if you do that, so you flood the security system. So, but applications that can run inside Kubernetes using egress, egress, or whatnot, those can be publicly exposed, right? But because of the control plane of Kubernetes, it is not supposed to be publicly exposed. Kubernetes control plane, which is the API server itself, should not be publicly open to the internet by design. That is in a production grade environment. It is not supposed to be so. I just want to put that out. Thank you so much.
All right. Thank you. Okay. So now fully on Kubernetes storage. Does anyone have any more questions? Okay. Now Kubernetes storage. Remember when I told you that containers are ephemeral, right? When I make containers ephemeral. When a container stops, anytime it starts again, it's starting as a fresh. So that means all the data stored on the logs, everything is basically wiped, right? So that's why most times when you have a container, you want to collect the data, you need to be forwarding the log to a storage account or to a storage. Basically, you need to call it somewhere. So imagine now, if you're hosting a database on a container, right? Are you telling me that anytime the container restarts, all the data stored on it will go? That's where Kubernetes storage comes into place, right? Kubernetes storage helps you to be able to store your data in that container. So what it's about? So it basically means, okay, hey, it's my container is started, I'm telling my container, please store the data, store the file. The files are stored here. So anytime the container starts up again, it basically just picks up from there, picks the data from there. That's just basically what Kubernetes storage does. So it's a way for you to basically make Kubernetes run like a normal server, normal like a server, in the sense that your logs are literally stored somewhere. Stored somewhere. That place could be any of this. It could be an AWS disk, it could be an Azure disk, it could be an Azure file, it could be CFS, it could be local, it could be a local disk, it could be an SCSI. These are the different ones you can use. But the whole idea of web storage is to help you be able to continue, be able to retain your data. Just imagine that, like now, I'm building a website, right? You come to my website, you register today. It's stored in my database, and my database that is stored in Kubernetes. Tomorrow, something happened. I have to restart my pod, or my pod restarts. Remember how I say, hey, pod has Kubernetes self-healing. Restarts. That means all the users are registered, everything stored are gone. So that means imagine tomorrow or next week, you come to the website, you try to log in again, and it's actually you to enter username and password. You basically say that this guy is not serious, right? This guy is not serious. You say this application, you might even call it a 419 website. That's the whole idea of Kubernetes. Kubernetes helps you, Kubernetes storage helps you to be able to keep your data. Okay. The next thing I want to talk about is config maps. So what are config maps? Config maps is a way for you to handle your configurations, your configuration data. So for example, now, hey, you are building a website, right? Let me see, you're building a website. You want to store your username, or you want to store the URL of your API. Things that are not secret, not API keys, URL of your API. Things are not secret. You can store it in a config map. Please note, I want you guys to know this is very important. Config maps, because the next thing I'm going to look at is secrets. Config maps is used to store things that are not secret. So for example, now, if I give you my name is not a secret, right? So Udetiku is not a secret. So if I want to store a name, let's say my name is what I use to log into a database, I can store the username in a config map and store the secret, the password in a secret. So the major difference between, for example, a port number, instead of hard coding the port number, instead of hard coding the API endpoint, you can store it in a config map. That's what it's all about, right? This is an example of how to create a config map. I'm going to create one. I want to combine it and secret so I can show you guys. Config maps, basically, this is an example of how to create a config map. You can kubectl create. This is imperative method. From literal means basically keep it as the way it is. This is an example. So if you look at the YAML file here, basically say kind of code everything. But if you go deep, you say okay, this is after the config map is created. But this basically you are calling the config map reference. You're calling the name of the config map and what is being referenced. It's basically the best way to explain it is basically a key value pair. That is what it's just the key value, but it's just to store your values. It's just to store values. It's similar to app configuration in it's basically similar to app configuration in Azure. It's basically for you to store your configs. So for example, if you ever built an application before, you might decide to store in your configs in a particular file. So you want to go to that configs and see, okay, hey, which ports in my database connected? For example, let me use I know MySQL talks on port 33006. Let's say for security reasons, your application is configured for you not to talk on 3306, it's configured to talk on 4040. If you make these changes, you need to, in your config map, you need to put it there so that if someone is trying to deploy the application, you can go to your configs and see the required configs of your application. So those required configs that are not secrets, because config map can be viewed. It's stored on the config map. The next one is secret. Secret is basically used to store for the name, passwords, API tokens, things that should not be shared, right, are being stored in secret. So someone asked me, does it mean that, hey, when I view a secret, I cannot see the password? Yes, you cannot see the password. You can see this. What you see is basically the base. 64 encoded. Of course, it can be decoded, but we're not going to go into that, right? It can be decoded. That's why if you're deploying a KS cluster, most times it's really linked to a key vault. So in this case, you call a key vault, we will basically pass in the secret. And if you don't have permission, you'll not be able to do that. We're going to look into that more when we go to AKS. But in summary, config map. A config map is basically a config. A secrets in the other is used to store secrets, passwords, API tokens, things that should not be shared. That's basically where you store the secrets. That's basically where you store it in secret type. So secrets and config map are totally different. Before I go to persistent volumes, I want to show you guys example of a config map and a secret. Yes. Let me bring it here. Okay. So this is an example of a config map, right? This config map will basically create a config map for a DB host, right? A DB host, look at line 8, DB host base and port 437, app color is blue, log level is info. From what you can see here, this guy is doing config. That is, nothing is hidden. He's not hidden anything here. Secrets, on the other hand, this is the secret. And secret on the other hand is basically encoded. You can see encoded. I have to put this guy just to show you guys. So this is the password, super secret 12347, 123, super secret pass 123, right? But you can see that it's not what it's showing here. Normally, if I'm deploying this, of course, I will not hide. I will not do these two guys, right? This guy would go and deploy this guy password is what is this AI project key 999 is what is encoded to be this. You can see that with secret it's encoded before you even save it. So if I'm to deploy this guy now, I want to do an example. Sorry, why? I want to do an example and show you guys config map. I do kubectl. Oh no, hold on, let me bring out where is it? Bash. Sorry, 1 minute. So I want to do kubectl get config map. Guys, remember the commands config map. So it's telling me there's one config map here and it's been available for 90 days. Kubernetes root secrets, right? I can describe it kubectl describe, right? Remember, if you want to see details of anything, right? You do kubectl describe config map and paste it here. Paste the name. Right? Because this guy showing me the certificate, contain certificate bundle. You see, there's nothing hidden, right? Just plain nothing hidden. I'm going to clear this. I'm going to clear this. I want to deploy the config map I have here. So kubectl. Can I zoom in here? I need to quick research on how to zoom in and zoom out. But let me just do it. kubectl creates -f, right? Config map. I'll call it db -config map. Yeah, or YAML. Yeah, see that's created it. I'm going to go ahead and create the secret now. Yeah, db secret, so YAML. So I've created these two now. If I go back to here, I want to show you guys kubectl gets config map now. To show config map in my environment, config map now. What do you see? Oh, sorry. What's happening here? So you can see if I click it now, you can see suddenly now I have two config maps. I can describe here. It's showing me data. There are 4 data included in the config map. So if I do kubectl describe config maps, config map, hit that feedback doesn't allow me to, yeah. All right, sorry, guy. It doesn't allow me to do, yeah. So you can see this guy describe what do you see? Remember when we did it here? Remember what we did here? See? This guy can config map this values db host DB source, DB port, app color, this one. You see, when you describe it, nothing is basically hidden. It's still clear. Everything is basically clear. So let's look at secret now. kubectl. Let me just clear so that it should be kubectl get secrets. And see, kubectl describe secrets, right? What do you see? You see no value data. What do you see? See, they're just telling 18 bytes. That's the difference between it's not even show you the value. Once you create, it's not showing you the value. You have to edit it and use it to decrypt it. That's basically secret. So what I say, secret are what basically passwords. Okay, guys, any questions? All right, I'll move forward. If you have questions, just raise your hand like CJ suggested. The next thing I want to talk about is persistent volumes, right? What is persistent volumes? Last thing we talked about storage. Persistent volume is basically say, hey, how what can people use to store? So, for example, now as a Kubernetes administrator, you're administering your Kubernetes cluster. People need to use storage in your environment. The idea of persistent volumes is for you to create a storage that people can use. So with persistent volumes, I can have a 1 terabyte, right? And then I decided, okay, hey, CJ is building his application. Hugo will now take 500 with persistent volume claim, which is the next one, PVC. We'll go and take 5 gig for his application. The other person will take 200. But I need to provision the persistent volumes first, right? So it's basically provision. It's like when you go to buy a laptop. Now you're going to buy a laptop, you decide to buy 1 terabyte. From your 1 terabyte, your different applications you are installing will not take it on that thing. That's what persistent volumes is all about. So it's like provisioning a storage for your cluster. There are ways you can get around this if persistent volume is not provision. That means that you can, for example, even in Azure environment now, if you write it, Azure will basically, because all these cloud providers are trying to get you, they are trying to make it easy for you to use service as much as possible. If you don't have a persistent volume created, you can do request for storage and Azure will give you storage. But the idea of persistent volume is that your administrator, the Kubernetes administrator, the cluster administrator will provision a batch of storage for you to use in your environment. The next one is position volume claim. So it's just like now, you just see it now. Okay, in your house, you bought a big bread, right? You bought bread, and from your bread now, but if there's a bread, someone come and cut from that bread, claim. I'm claiming this portion of the bread for my environment. So imagine now you have 1 terabyte. Someone comes and say, hey, I'm claiming 200 gig from that. Remaining 800 gig. It means that once I've claimed it, nobody else can touch it. So persistent volume persistent volume is what is the Kubernetes resource. The claim is how you claim it. Just that's how you claim it. For example, my phone, me claim them, right? So that is so you claim the storage as a provision. So if you provision, if you need 10 gig, you can come and claim it. So even if you claim that 10 gig and you're not using the whole 10 gig, no other application can come and take that 10 gig away from you, right? It's a way for you to get something for yourself, get the storage for your application. That's what the PVC is all about. I call it PVC, but it's also, they call it persistent volume claim. That's what it's about, right? Remember, the first one is being done by administrator. Persistent volume is being provided by administrator for the whole cluster. Claim is how you consume what was created, right? How you claim of what you need. Okay. All right. Any questions before we move into AKS? Guys, any questions? All right, Leo is typing. Any questions? Okay. No, PV is not created by default if you didn't create it. It's not created by default if you didn't create it. It's not created by default. So if in your local cluster now, if you need storage, right? If you need storage, it's not be created by default. It's not be created by default. Automatically, because of because of how Kubernetes has grown, right? Automatically now, if it's AKS, for example, now what is going to happen is going to go and basically spin up an Azure disk for you. You're going to have an Azure disk assigned to you because that's the default one. So, but for example, now if what if I want to use Azure files as a disk, I won't be able to use it. So I have to create a PV that's attached to Azure file for me to be able to use it. I don't know whether you guys are getting what I'm saying. So, for example, in Azure, the default PV there is Azure disk. If you say, hey, give me 1 terabyte, automatically Microsoft will assign 1 terabyte to you, right? But if you don't want to use Azure disk, or you want to use a particular SSD, remember when we did AZ104, we talked about different storage tiers. We talk about SSD, premium SSD, right? We talked about normal hard disk. People that have bought laptop in the past will remember, hey, in the olden days, laptop, or sometimes you buy a laptop, it had 2 disks. One side is SSD, one side is not SSD. The SSD is basically faster than HDD, right? The same way it's in Azure. SSD is more expensive than HDD. So what if you want to use premium one? If you don't define the PV on time, Azure will automatically assign anyone to you, right? So it's not automatically defined. You have to prepare. That's part of the job as a Kubernetes administrator. So most times when we set up a cluster in AKS, and I already know the requirements of this application. If it's intensive, I'm going to make sure that I create different tiers of storage. For example, now the log, it doesn't make sense to use the expensive log and be storing it in SSD because logs doesn't need expensive data. I can store the logs in the file share that is cheap. The cheap file share HDD back and decide to store the database file on SSD. So this is actually part of your job. So part of your job as a DevOps engineer, sort of things. But I believe when you is basically the truth is that all these things are I won't lie to you, it's quite easy now with the whole generative AI. You can basically say, hey, I want it here to be this, and this, and this. Put it on ChatGPT or whatever to basically generate the YAML file for you. That's why that's why if you notice this class, I'm not spending more time explaining each line of the YAML file. What I'm spending more time is for you to understand the different resources. Because if you understand different resources, you can literally ask AI to build anything for you. Okay. All right. Moving on now. We are going to AKS proper now. So what is AKS? AKS is Microsoft Managed Service, Azure Kubernetes Service. Is the one built by Microsoft. So for example, now, the one I've been showing you guys, I'm testing in my local environment now. That means my laptop has to be on for it to test, right? But if you're hosting an application, if I'm hosting the beautiful Nonso AI app, I won't be hosting it in my app. I need to host it in AKS, or in a Microsoft application. And the beauty about AKS is that AKS is really global. It's designed for resilience. It's designed to host AI applications. AKS is very robust. Like, remember when I was talking about service, I say, hey, if you type a service of type load balance, automatically public IP address will be used for you. Not just that. What Microsoft is actually doing in the background also is that when you say type load balancer, Microsoft will deploy a standard load balancer for you through NAT, network address translation, and map it to your local address. So many things are happening in the background within that 2-3 minutes that you deployed it. So AKS is actually very robust. What is AKS? I think I mentioned they say AKS is basically Microsoft Managed Service. They have other ones like Azure Container Apps, but AKS is the most robust one. If you are building a robust application, you should use what you build on AKS. The good thing about AKS is that API, the master node is free. So in AKS, you don't pay for the master node. You only pay for the worker nodes. Microsoft owns and takes care of the master node, right? That's AKS. Within AKS, AKS private load balancers are integrated within AKS. You can integrate both private and local load balancers. It has several, just like the several beautiful features. If you guys remember when we talk about AKS, when we talk about Azure, we talk about say, okay, hey, our back with AKS, you can do role-based access control. That means I can decide that, hey, okay, Win will have only a contributor role. I can decide that Win can have a reader role. I can decide I can implement RBAC with AKS. That's the beauty about AKS. AKS is actually very, very robust. You can make use of application gateway. We'll talk about application gateway. Guys, remember when we built a website and we shared it to application gateway and we were able to load balance? With AKS, you can do all that. You can integrate to a load balancer. You can integrate with key vaults. Remember when I told you guys that key vault and that secrets are very exposed. If you don't trust using Kubernetes own encoding using base 64, which can be decoded, if you want to store it in the key vault, you can store those secrets in the key vault and reference it in AKS. AKS can do that. AKS is actually very, very, very robust. Different ways to deploy AKS. You can deploy AKS through the portal. You can deploy it through Azure CLI. You can deploy it through a PowerShell. You can deploy it through ARM templates. You can deploy it through using Terraform, right? Or even Lumi. You can deploy it through any of that. I'm going to just go through a quick sample of deploying AKS. So I think that will make sense, and I'll use it to explain a few more things. I'm going to do that in my environment. 1 second, please.
You have a question also from the chat.
Okay. All right. Thank you. On the charts. Let me see. What am I missing?
Leo.
Okay, Leo. Yeah, I've already answered that. If I didn't create, okay, I already answered that question. He said, hey, is PV created by default? It's not created by default. If I didn't create it, I already answered it when I mentioned about that no PV is created by default, right? You are expected to create it because if you allow it, it's going to use the default one. In Azure Dix, that was what I was trying to answer then.
Yeah.
Leo, are you clear, or do you want me to clarify more? Leo, can you hear me? Okay, clear. All right.
Clear.
Thank you.
Yeah. Thanks.
All right. Okay, so I want to create a Kubernetes cluster just to show you guys because I believe visualizing is better. So I'm going to basically use the portal. I don't want to use CLI, so I'm going to type Kubernetes service. Let me see. Okay, Azure Kubernetes service. I'm going to go ahead and create. George is typing a question. George, I'm expecting your question, but in the meantime, we'll go ahead and be creating this. Oh, you can't see my screen. Oh, sorry. Sorry, can you see my screen now? George, can you see my screen now? Okay, yes. Okay. So I'm going to my subscription. I have a subscription as an MCT. I have a subscription, so I'm going to go ahead and create it. If you need a subscription, just like we did 1104, you can request for the free subscription. You get $200 to play with for at least for 1 month. So I'm going to go here and come here and do Kubernetes. Okay, going to create now. Okay, so this is basically what you're creating, right? I'm going to create a resource group because that resource group is basically where, remember when we did WCAST 104, we say, hey, anything you're creating in Azure, any resource you're creating in Azure needs to live within a resource group. So I'm going to create a resource group that my AKS will be stored in. I'll just call it AKS. Doesn't mind. So for cluster preset configuration, this is basically saying, hey, there's some configurations I want you to be by default. So if you're deploying a production cluster, there are some things that Microsoft wants you to be part of it. So because I'm deploying a DevTools cluster, I can go production enterprise, production economy. Remember, it depends, as you're selecting this, it depends on how much Microsoft is going to charge you. So I'm going to go for dev test, right? And I'm going to go for, I'm going to call it just test-AKS, right? The next I'm going to go location, Europe, Central, Sweden. Honestly, I don't care. I'll just use this. Fleet manager, no. What is fleet manager in AKS? I'm going to explain this. Fleet manager is if you want your AKS to be part of other AKS clusters, you manage it what we call AKS fleets. That's why you use fleet manager. Right now, we don't want to do that. We're just creating a test AKS. So in case someone asks you, you're in an interview, hey, what is AKS fleet manager? Basically, is used to manage multiple AKS clusters. But in this case, we're not creating multiple AKS clusters. We're creating a single cluster, so we don't need fleet manager. You can create one here, but I'm not creating anyone. Availability zone. Remember when I said availability zone is for replication. I don't want to do this. Remember, the more you are doing this, the more cost the application is, the resources are. I don't want to do this. AKS pricing, I'm choosing free tier, right? Because of what I'm considering cost, right? Kubernetes version. This is very important. What I mean Kubernetes version. So there are several versions of Kubernetes. There is 3.36, there is 1.34, 1.34, 1.2. Kubernetes releases version, I think every 3 months or thereabout, every 2 months. I might be wrong about this. I need to verify with you guys. Your cluster needs to be on a particular version. So sometimes Microsoft sometimes after a while, I think if you want to go to version 29, there's 1.22.9. You can see it's no more there. So if you deploy your application and it's running on 1.29, it's possible that Microsoft will tell you, hey, you need to upgrade your cluster because we can no longer support your cluster. That's one of the reasons why in some cases, Kubernetes is not meant for teams that are just starting, to be honest. It requires a Kubernetes. If you guys are actually focusing on what you are doing the last 3 weeks, you see that Kubernetes is not easy. Like how people say, it's not more and more, be beans, right? So it requires a certain level of knowledge. If you are hosting in Kubernetes, that means you need to be able to update and migrate your application. So you need to make plans on when to upgrade, not your application, to upgrade the cluster, right? You upgrade the cluster your application is running on. So I'm just going to go for 1.3, 1.3.6. I don't want to bother about this. So the next thing is talk about patch. What does it mean? Okay, Microsoft is saying, when do you want us to patch your cluster? Your cluster is running on a node, right? Remember, a node is basically a VM, a virtual machine. Not just like your phones and laptops, it needs updates. Microsoft is saying, when do you want us to update it? So I'm just going to leave this. Of course, if the production environment, I need to clarify with the team on when they can allow downtime. I'll now schedule nodes to basically match that. Right now, it's a dev environment, dev test environment, so I don't need to worry about this. The next thing talking about node image. Node image is talking about, okay, which image do I want to use? In the case, update the node with a newly patched VHD containing security fixes and bugs on a weekly cadence. This one, I don't mind this. Microsoft should update. The whole idea of Kubernetes, remember I said Kubernetes was self-healing. So Microsoft is not going to come and update all the nodes at the same time. So, but the time as times of updating this node, that node will not be available. It will move, the application will start up on another node. That's why you need to be careful when you are doing your services. Remember, I said services of type node ports. You need to be careful when you're choosing those things. Because if you're not careful, some of your services might not be available because of the configuration you made. That's why Kubernetes right now, I think Kubernetes has 5 certifications. There's Kubernetes security, there's Kubernetes administrator, there's Kubernetes developer, there is the one for the entry level one, because Kubernetes is not really entry level, but it's really used to host a lot of applications. So it makes sense for you to understand the intricacies of it. So, but in this case, I don't care more about it, to be honest. Again, it's a dev test environment. So this one is talking about, okay, hey, authentication, authorization. Do I want to look at local account around back? I will just use it, to be honest. No, let me use Microsoft Entra ID, Kubernetes RBAC. I'll just use this one. So I'm going to go to the next page, node pools. There's a concept that is not available in on-premise Kubernetes that is available in Azure. The concept of node pool. What is node pool? Node pool in Azure is, instead of having one node, Azure won't perhaps like 3 or 4 people node together and call them a pool. What does that mean? For example, now I can decide to, okay, hey, I can have a node pool running on a cheaper VM for a resource I don't care too much about. Like I have a node pool running on an expensive VM for resources I care about. Yeah, I remember when we did 104, and we talked about say, okay, hey, Kubernetes. We talk about some VMs. Some VMs are expensive at $1,000 a month. Maybe that's what I want to use to host my AI applications. I can create a node pool of that. I only host some certain my AI applications on that node pool. The application that I don't really care too much about or don't care too much about that I know doesn't require heavy resources, I can host them on a cheaper resource. So for example, this one can add additional node pools, but this one I want to edit this one. I want to edit this node pool. Just let me just edit it and show you guys, for example, now. So you see, name of the node pool is what? We're calling it agent pool. What is it using here? It's asking me for system node pools, used for system node pools, how many zones? I'm going to reduce the number of zones, honestly, give it only one zone because of money. Which size is it going to use? Are you seeing, guys, which size is it going to use? If I select this size now, it's going to show me the VM size. Guy, it's going to show me the VM size it's going to use. And so, example, if I select this, for example, now that's going to be this USD. If I select two of these, now that's going to be 56 USD times 2 every month. That is 150 USD is going to be charged on this every month. I want to go for something cheaper. To be honest, I want to do a Clico. I'm going to select this. Let me see what I can run with this. I'm selecting B series. And one thing I wanted to note you guys about, we mentioned it before, is about this guy, is about scaling. Scaling the minimum node count. So it's possible for me to say, hey, okay, in a node pool, how many nodes do I want to be inside that node pool? I can say 1. If I say 1, right? That means when I deploy it, 1 will always be available. If my resources need more and it's trying to pull for more, it's going to increase to 5. Going to scale to 5 automatically. This is not HPA that Dominic explained to you guys last week, but it's linked to HPA because if HPA notice that, okay, there are several requests coming on this and start increasing the number of the pods, right? Once they start increasing the number of the pods, the node will automatically need to be increased because it will be lacking space to work. So as it's increasing nodes, as the pods are increasing, this one will automatically scale also. There's a Kubernetes service, there's a Kubernetes piece of software that also helps with that. They call it Carpenter with a K. But I'm not going to go into that, to be honest. So I'm going to leave this one like this. Remember, I'm saying I have to minimum of 1, maximum of 5 when it's scaling. Why am I doing this? Because of what? Money. Oh, God. Say, this cannot be scheduled, right? So I have to go back. I have to change my, can I make it manual? Let me see whether manual will work. Oh, man. So B size is not available, cannot be scheduled. So my P2, no work. So I need to change the scale of what I'm doing. I'm going to change this. Let me just go with this. It's the test environment. I'm going to delete it after because I don't want to waste much resources I use for labs. So I'm going to just use this. Node count, minimum of 1, maximum of 20. It's fine. It's not going to get to that. Another thing to note is the max. You see this guy? I've seen this thing mess people up. Pod, max pod. Most times, I remember doing an interview one time and they asked me, okay, hey, you set a cluster to have only 30 pods. They basically said, well, the question went like this. They said, you deploy the cluster, we notice that we can only have 30 pods on that particular AKS cluster. What is the reason behind it? It's the settings you configured when you are deploying your node pool. So if you say that it should only be 30 pods, it can only be 30 pods, right? Even if it has more space, more resources, once it gets 30 pods, it's going to bounce to another node. It will be no space. So the next thing I'm going to talk about is something that Dominic already mentioned earlier today is the private access. Private access. The private access is basically saying, okay, hey, you have a cluster. You want that cluster to be available to the public, the API, the UI API to be available from anywhere in the world. I can decide to, if I check this now, it will be private. If I uncheck this, I can say, okay, no, even though it's public, I want it to be to some certain IP address. I can use my home IP address and put it here. So this API can only be accessed through my API address. Leo, okay, I see your question. Let me go ahead and answer it. you said something, said, okay, I should explain the maximum pod, right? Show you an example. This is my cluster, local cluster, kubectl, get nodes. I want to get nodes, for example. You see, I have only what one node, right? Called Docker desktop. And I have what is running version 1231. Clear my screen. If I do kubectl, get pods now. You can see all these pods are running inside this one node. How do I know? I can do kubectl, get pods /o wide. If I do O wide, sorry, I'm going to zoom in a little bit just for clarity. So you can see the same pods, right? Where are they running? Which node are they running? Node. They're all running on one node, Docker desktop. It means that this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. These 13 pods are running only on one node. So the whole idea of max pod is saying, okay, what is the maximum number of pods that should be running inside one node? So if I'm deploying AKS, this guy is in AKS, and I set the max pod to be 10. That means once I deploy 10 pods, it will not schedule another pod in that node. That's what the max pod is all about. It means the maximum number of pods you can have running in a node. That's it. Is it clear? All right. Going forward. Oh no, I've not explained networking because I want you guys to understand the networking very well. Because that's where I see some challenges. So set authorize. I think I've explained this one. If you want it to about the particular IP range, you can select this particular IP. It doesn't define that it's public. You only be available on a certain IP address, public IP address. I can set my own IP address. I'm not going to do that. I'm going to leave that. So the next thing I'm going to do here is basically do network configuration. So this one is another thing that I've seen that mess people up, right? Azure CNI overlay and Azure CNI node subnets. The difference between these two is that if you choose overlay, right, Microsoft, your Kubernetes cluster is going to be on its own IP address. Each pod will have their own IP address. They can communicate with each other, but you can't use that IP address. That IP address is not routable outside your cluster. It's not routable. I'm using some networking terms. It's not routable outside your cluster. It is NATed. You cannot ping it, right? It's not routable outside your cluster. If you choose node pod will have an IP address, primary IP address from your VNet. It will not be, each pod will have an IP address that is routable outside your cluster. Private IP address. That's the difference between the two. So depending on the requirements of the people that you are, depending on the requirements of the cluster and the number of subnets you have, that's where you choose whether you are going with CNI overlay or CNI no subnet. Another thing I want to mention is the network policy engine, right? I can decide to use CNI policy engine, which is also very good, or I can choose to choose Calico or Azure, right? Which is another one. This is basically network policies. Network policies in Azure. I didn't touch it much more. I didn't touch it much when we are doing when I was doing it because again it's more about security. I'm just basically explaining the whole basics of Azure because I know that when you're basics of Kubernetes, I know that when you understand these things, you can now dig deeper. Or maybe down the line we can do a session on network policies in Kubernetes, right? But let's just look at this now. So, but network policy is how you schedule connections, which open source policy, or do you want to use Azure CNI for the connections between the pods, right? You can use this restriction. So, for example, in Kubernetes by default, pod A can talk to pod B, can communicate to pod B. But if I don't want pod A to talk to pod B, I can set what network policy that restricts them. By default, the rules inside cluster are free. Every pod can communicate with each other. If I want to restrict it, right, then I need to deploy what? I need to set up network policies. Okay. Next in integrations, that's nothing I mentioned. I say, okay, hey, with AKS, you can integrate with what? You can integrate with container registry. You can integrate with Istio. You can integrate with Azure policy. Guys, you still remember Azure policy? See, basically Azure policy, because use of governance is how you restrict, your environment. You don't want, if you don't want people to create VM only, you want people to create VM only in a certain region, use Azure policy. So you can integrate Azure policy inside inside Kubernetes. So this, and then more integration with container insights, integration with Prometheus, integration with Grafana can enable all of this. It will create all of this. That's the beauty of AKS. All the things that even normal cluster you're doing in an environment, you have to configure all this. With the AKS, all of those things can bundle together. Again, but remember, as you are bundling together, so the money they cost, right? I'm going to integrate with keyboard also. I'm going to integrate with keyboard. Keyboard is not secret. I'm just going to click everything, just check everything. Then next one is advanced managed Kubernetes. I'm not going to do all of this, to be honest. I just want to move forward. Managed Kubernetes namespace, right? It's taking validation. Well, okay. Leo has a question. Leo, I'm going for a question. In the meantime, I'm going to go ahead and create this. It's going to take a few minutes also. Okay. Leo said I should explain the CNI overlay again and the other option. Okay. The best way to explain this is to understand something, right? Let me show you guys example. Let me bring up my cluster again, right? Look at this, my cluster now, right? What can you say in IP? You can see each of them has their own IP address, right? They all have their own IP address, 10.1.0.64. Okay. This is running in the same something similar called overlay. When I mean overlay, I mean that if I copy this IP address now, and when I say remember the overlay, the IP address of your pods are not routable outside your cluster. If I try to ping this now, ping this IP address now, let me ping it. You'll see it's not responding. It's not responding because the IP address, my laptop does not know how to get to this service. Why? Because there's an overlay, right? There's an overlay because it has its own networking. That's if you're using just CNI overlay, it doesn't get its own private IP address assigned to it. The other option, if I use the other option to set up, automatically all my ports will have what? Their own private IP addresses. Each pod will have an IP address routable both outside their cluster. So if I want to, if I'm using a service, if I have a VM now, from that VM I can ping a particular pod. I can connect to a particular pod service. It's possible. Even services are routable. But the issue with that one is a few things. You will make use of lots of IP addresses. So for example, now you remember when we are creating, remember the max pod 110. So Microsoft will say if you choose this option, not the non-overlay option, what is going to happen is that you are going to make sure that you have enough spaces. You're going to might need to have 112. You might need to have 256 IP addresses available on your subnets that AKS is deployed on. So the basic difference between the two, I don't want to go too deep. The basic difference between the two is that, hey, for CNI overlay, the IP addresses are not routable outside your network, outside your cluster, sorry. For the overlay, for the non-overlay, is routable outside your it's routable outside your cluster. That's the difference between the two. Are you clear, Leo? Are you clear? It's still deploying. Okay. All right. Guys, any questions?
Mind
Can
you,
use the last 10 minutes of question.
Okay.
Sorry,
Kubernetes takes at least 20 to 30 minutes, depending on what you're creating, to be deployed. Yeah. It doesn't use about 5-10 minutes. So I think you should know that to the team, to everyone, to the listeners, please notice that Kubernetes takes at least around 20 to 30 minutes at most.
Yeah.
Yeah.
Yep. Okay. So no questions. Okay. While this is creating, is there anything guys would like me to clear? I know we have just 9 minutes to conclude the class for today. Is there anything you guys like me to explain more? Maybe next week we'll just conclude this and go into something AI, right? Anything you want me to clear, anything you want me to explain? So this will take a few minutes, like Dominic said, to deploy. Network policy. Okay, all right. I'll make the network policy. The network policy, yeah, basically 3 types of network policy. Not for now, Calico. So the whole idea of network policy is just I explained something. I said, okay, network policy by default, this service A can talk to service B, network policy, right? In Kubernetes, sorry, I'm most tired, but Kubernetes, services can talk to each other. Port A can talk to port B. If I want to restrict it, and then I can decide to do what I need to deploy a network policy. So Azure is Azure version. So remember when we started Kubernetes, I said Kubernetes is open source. So if you are comfortable using Azure own, you can use Azure own. It's just like different versions of the same thing. You can use Calico, or you can use none. None literally means that you don't want to set any network policy at all, right? You don't want to set any policy at all. Azure is Azure type of network policy. Calico is another type of network policy. So you can use any one you want. For example, if you're doing the CKS exam, there is one that's called Falco, F-A-L-I-C-O. Is another type of network policy. So that you're going to get questions on those parts. Just know that just see it as different types of the same thing, right? You can call it different clubs. They basically do the same thing. They all play football, right? Different types. So if you want to go, maybe let's say you are more into open source and you want to use the open source version, you can go with you can go with Calico. As Microsoft is presenting you that option. Any more questions?
And again, mind you, just let me just add up to what Nonso has discussed. Again, when you are trying to create Kubernetes, you can create Kubernetes in 3 or 4 different formats, right? You can use the CLI, which is the Azure portal, to create Kubernetes, which is pretty straightforward to create it, deploy Kubernetes at any given point in time. You can use Terraform to deploy Kubernetes, which is infrastructure as a code. I think in an environment where you have high-end production grade environments, we use ISC, which is the infrastructure as a code for Terraform. Please notice that also you can use the CLI. People who use CLI at some point can convert that CLI. That is, you can use Portal. You can use the Portal and convert it to code. Without you writing code, you can convert it to code from the portal. As he has created it, you can use the steps that you used in creating and convert it to code. AI, I think Azure does that, right? So you convert it to code, and so you have all the already made written code, but you have to put in the work to do that on the portal, just the same way Nonso have done all of this in showing the example of how to do all of create all of such in Kubernetes. Then in the high-grade production environment, we do use what we call Terraform, which is infrastructure as a code, right? Terraform is mostly used because it's widely used across all cloud platform, any cloud platform. Yeah, is multi-cloud enabled, which means you can use Azure, AWS, GCP, name it, any cloud, but basically it is highly used. But apart from that, if you work in an environment that they only use Azure, they don't want to go out of Azure, you can use what they call Azure Bicep, right? It can also work as an infrastructure as a code tool, but it's an in-house or a predefined default tool by Microsoft. So instead of you don't want to use pay for or you don't want to use Terraform at some point, they only use Azure in that environment, then you can use what they call Azure Bicep. I mean, it works the same way just as an infrastructure as a code to you can use to do deployment, right? So that's just what I just want to put out there. Remember, if you create that from Portal, you can convert it to code and then deploy and use it in a high-grade production environment. But one of the fastest way people use most times is Terraform. IAC, infrastructure as a code. If you use a vast multi-cloud environment, Terraform is easy to use. It's highly used. It's highly suitable for Microsoft Azure. But if the company, your organization doesn't want to use Terraform, then you can switch to use what they call Azure Bicep. I hope that's clear, guys.
It's clear. I think Leo is typing a message. Sorry, guys, the creation is taking a little bit of time. Just like we suggested, 10 to 15 minutes. Let's see. But if you have more questions, keep them coming. So is it safe to use patch or upgrade when you mention about upgrading? Sorry, I'm struggling a bit. So remember, okay, let me just assume this is what you're saying. If I'm not explaining it, just please call me short. So upgrading a cluster, there are several upgrading the version and updating the nodes. Updating the nodes to the latest version. Let's say, for example, there is a patch available. You're not going to be the one to update it. Microsoft is going to update the one automatically. But upgrading the cluster is on you to upgrade the cluster, right? Upgrading the cluster is on you to upgrade the cluster. So it's left for you to make plans to upgrade the cluster. So, for example, what you need to be careful. It's not just as simple. It's not as simple as just coming to say, hey, click on the cluster, click upgrade, you upgrade it. Of course, it will upgrade it. But sometimes your Kubernetes manifest files, because as Kubernetes is releasing new versions, some things are no more available. So, for example, now let's say I mentioned API. If you remember when I talk about API, I say API version 1. Let's say container apps is let's say deployments are no more version 1. They're no more V2 in version 34.1. If you go and update it and your deployment is still on version, is showing V1, it will not run. It's safe after you've tested it in lower environment. That's why companies have dev, test, dev, QA, UAT, and production. Don't just go and update a production cluster. It's meant for you to update lower environment, test it first before you go. Okay. Are you clear, Leo? All right. Keep deploying. Let's say a few more minutes. But I think the cluster has finished deploying. It's just wasting a little bit more time. Let me see what I can open it.
Yeah, you can refresh.
Okay.
It will show up.
Yeah. Let me just see what I can. Let me try to open a new tab. Okay. Dupe asked the question. He said, what security controls do you implement in the new overall security of AK cluster, and how do you monitor the security? Very, very clear question. Okay, so remember when I said when we said about Dominic mentioned about it being private and being public. So the first thing is that if it's an enterprise environment, it will be private. It has to be a private cluster. The Kube API cannot be over the internet. Then that's one. The next thing is determining who has access to the cluster. But also have access to the cluster. Who has access to the cluster? It's another you determine. Who has access to the cluster? So who should have reader access, RBAC, who should have admin access. Then you need to enable Kubernetes policy on the cluster also to enable what the person can do. So, for example, one of the things you can configure is that you configure that somebody should not be able to exec into a container, because if somebody can exec into a container, they can get to the node and run some malicious code. So you need to make sure that nobody is able to do executive connector. You can protect that using Defender for DevOps, not for Azure policy. Things you can do. Those are the three things I can give out of top of my head now.
Yes.
You can also implement network policy to make sure that, sorry to cut you short, Dominic. You can also implement network policy to make sure that services are not just talking to each other. That services are talking to only the one you permitted it to talk. You think network policy is like a firewall. Not a firewall now. You can jump around. But if you implement network policy and implement the rules, that means service A cannot talk to service B unless you ask it to communicate with each other on a particular port. Those are the securities you can. Defender for cloud, yes. You can Defender for cloud for containers. It can help scanning the container for malicious code. All right, so this guy's finished deploying. I want to connect to the cluster now. So let me just set it up. AZ CLI. I need to do AZ login. I want to connect to this cluster now and show you guys something. AZ login. Oh, I don't have AZ installed in this system. Wow.
And that's Windows.
That's a miracle. That's a miracle. I thought I have AZ login. I don't have AZ login connected here. Let me see. Oh, I don't have AZ login. So yeah, let me see. AZ login. Wow. Okay. That will take some time. I will not run it today. Next week I'll just do example, connect to the cluster and show you guys. Let me not run it today. I don't have AZ login connected to it. But okay, no, you know what? Let me just do it through the Cloud Shell. Don't worry. Let me use Cloud Shell and show. Let me use Cloud Shell instead of doing this. I can use Cloud Shell and just show. I'll use Cloud Shell and show. No need of logging to the cluster. Let me use no need of doing that locally. Let me use Cloud Shell and just show you guys. Let me see. I'm connecting to the cluster terminal. Let me see. Well, everything is slow today. Is it because of Valentine? All right, so let me see. Okay, let me connect to the cluster clear. Right, I'm going to just connect to the cluster account set this account. So pick up plain text. Yeah. Overwrite the existing cluster configurations. This going to overwrite it. So I'm going to run this now just to connect to the cluster. Okay, no, I've already run this command, so I don't need it again more. All right. It's a plain text command login. All right, so I'm going to maximize this, right? So I can do clear now. And if I do kubectl get pods, you can see, you won't see any pod running here right now. Let me see. In a while. Oh, how is everything slow today?
There's a traffic going on in Valentine.
I'm telling you, the traffic is affecting the internet. All right. What is it running now? Okay. This is pretty weird. It shouldn't take this long. That's why I like building locally before going into the cloud. Can be timing out. What is running? What's happening? DNS, blah, 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 blah. It's not. Let me switch to bash, please. So that will be better. To be honest, I don't know why it's happening. It shouldn't be happening, but let me see. Switch to bash and see what that will help. Good node. Okay, all right. So I can see nodes. Right, I can. If I see the kubectl get ports now, I'm connected to the cluster now. Get ports. Let me see. Ports found in the port namespace. Let me see all the namespaces I have. kubectl gets and then namespace. see all my namespaces. I want to see all the namespaces I have. I want to see all the ports I have in every of them. Control get all namespace spaces or namespace. Let me see. Yeah, get ports. Okay, yeah. So these are all the ports running. You can see some of them saying they are running for 15 minutes ago, 40 minutes, 8 minutes. That is my AKS cluster. So you remember when I selected CSI driver, this is the port that is containing that control the CSI driver. Remember, guys, it means showing that there are three. What does this mean? It means there are what? Three means that there are three containers running inside it now, right? There are three containers running inside this, and that's what this 3 means, right? Okay. I'd like to stop today. Here today. Do we have any questions? Any questions? Anything you guys need clarification on? Anything more? Okay.
So,
All right.
So,
All right. Dominic, over to you. Sorry.
Okay, so just a quick one here. I will just quickly use 5 minutes, a few minutes to show you what Nonso has done in the class using Terraform and to explain to you how, to show you how easy it can be sometimes. So this is me while he was creating all of that. I was decided to create a simple AKS, Azure Kubernetes service, creating a Kubernetes in Azure using Terraform. So can you see my screen? Can you all see my screen? You can see my screen. Let me know. Yeah, so
yes, you can see your screen, yeah.
So I created a class, I created a folder, named the folder Kubernetes class, and on that class, I created a simple step-by-step process of how to create a Kubernetes class, Azure, Kubernetes in Azure. So first, I first of all created my main.tf file, and then I created my output.tf file, then my provider.tf, and then my variable.tf. If you look at my main.tf, this is where the whole magic happens, right? All what is supposed to be in the Kubernetes cluster, this is all what's being created here. If you look, all what Nonso was explaining to you here was written in Terraform. You can see all of this here. I talk about the identity, Azure cluster, the resource name, what's the network, and the likes. Everything that has been said in that in the what's it called, in the portal that was explained to you. This is how it's been done in the Azure using Terraform. You can see I name my I target demo, and then I can see all of this. I use a good practice like enabling rollback, which is rollback access control, and then the output, what you see in here in the Kubernetes, my cluster name and the likes, variables. So if I come here and then run and then I run a simple Terraform init, Terraform format to format the check, and then Terraform apply. A Terraform plan to plan what I want to deploy is going to show me everything that's going to be deployed in Azure Kubernetes service. And then when I use Terraform apply, it's going to show me what is going to be deployed. Maybe in the next class, I will just quickly run a simple deployment in Azure and then show you how it's been done. Please note that one of the beauty about what Nonso have done is you can convert the step-by-step procedure that you've done in the portal to code. By going to click next here, click here, add, and stuff like that. On the Azure portal, you can convert it to code just like this, right? You can convert it without you writing the code. All what you've done in the portal, you can convert it to code, right? To make it more easier. But if you are working in the production grade environment, remember I said production grade in quotes, emphasis on production grade, because when you work in a live environment, in a working environment, that can be tagged as a production grade environment. So if you're working in a production grade environment, one of the fastest way they do these things is we do it via infrastructure as a code, which is what you are seeing here on my screen, and it makes life more easier for you. So that the reason why we are using ISA is for accountability, traceability, and the likes. If you find error, you will know where the error is from, and you point it out, right? Accountability, you know who deploys this thing because you're going to have a tag in between, right? although you have all of that in and then speed, when you talk about why we use IAC, is for speed, right? Here, he was doing all of this through Porter, and within few seconds, I took our time to create all of this within 2-3 minutes, and here it is, right? All is left for me now is to apply this thing and this code, and then it's going to be deployed in Azure for you to see that Kubernetes. So I don't want to take much of your time to deploy this because it's still going to take another 15 to 20 minutes and all of that, because I will stop here for to end the class for today, and then you can come in with your questions and ask more questions when you for in our next class. So if you have any questions, please you could stay ask. If we are unable to answer all of the questions, we would do that in a group and our group channel, and then continue from next week. Thank you so much. Yes. CJ, do you have any questions for the class?
Yeah, not much of a question. Thank you also for the explanation, as well as Dominic. So for the community, soon we'll be commencing with a new series, GenAI, using Microsoft technologies. So like topics like MCP, model concept, model context protocols, GenAI, also looking at Azure Foundry, where you can build your own custom agentic workflows, all those kind of things. So this is just a prerequisite, just announcing it ahead of time. So we'll be running this series this year, starting from this month. So you can join us in our community. We have a YouTube channel. I will share it here, as well as a Meetup community channel and a WhatsApp group. That way you get abreast with information and things coming up. It's a pleasure to have you guys. I hope you enjoy your evening.
You too. Thank you, everybody.
Thank you, everyone. Yeah. Right.
Thank you, everyone.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Bye.
Yeah, bye.